Hello everyone, welcome to Decode ITES. This is a single learning platform for multiple IT infrastructure technologies. Do like, share and subscribe our channel to never miss out our videos. Let's continue with the learning. Let's have a small introduction of myself. My name is Prince Garg. I'm having 3 plus years of work experience and worked on Red Hat, VMware, Windows, Google Cloud, PowerShell, Python and Bash scripting. Kindly follow us on Facebook, Insta, LinkedIn, and reach out to us on itesfund.com. Welcome back, everyone, to the learning series of VMware virtualization. In this lesson, we will talk about virtual machines versus containers and bare metal server. How are they different and which one is better? First, let me guide you with an overview of the virtual machine. VMs are technology for building virtualized computing environments. They have been around for quite a while and are considered the foundation of the first generation of cloud computing. Simply putting, a virtual machine is an emulation of a physical computer. VMs enable teams to run what appear to be multiple machines with multiple OS on a single computer. VMs interact with physical computers by using lightweight software layers called as hypervisors. Hypervisors can separate VMs from one another and allocate processors, memory, and storage among them. VMs are also known as virtual servers, virtual server instance, and virtual private servers. We have already discussed in our previous lessons. You can check this out on the card which is showing above. Containers. Containers are a lighter weight, more agile way of handling virtualization. Rather than spinning up an entire virtual machine, a container packages together everything needed to run a small piece of software. The container includes all the code, dependencies, and even the operating system itself. This enables application to run at almost anywhere, a desktop computer, traditional IT infrastructure, or the cloud. Containers uses a form of operating system virtualization. Putting simply, they leverage features of the operating system to isolate processes and controlling the process's access to the CPU, memory, and disk space. Containers have been around for decades, but the common consequences is that the modern container era began in 2013 with introduction to Docker. We'll also discuss what is container and Dockers in detail in our coming lessons, but these are not too much necessary now. So what are the difference between, or we can say what is versus between the virtual machine and containers? In traditional virtualization, a hypervisor virtualizes physical hardware. The result is that each virtual machine contains a guest operating system, a virtual copy of the hardware that the OS requires to run, and an application and its associated libraries and dependencies. Instead of virtualizing the underlying hardware, containers virtualize the operating system, like typically Linux, so each individual container contains only the application and its libraries and dependencies. There are no operating system. Containers are small, fast and portable because unlike the virtual machine, containers do not need to include a guest OS in every instance and can instead simply leverage the features and resources of the host operating system. Just like virtual machines, containers allow developers to improve CPU and memory utilization of physical machine. Containers go even further, however, because they also enable microservice architecture where application component can be deployed and scaled more granularly. This is an attractive alternative to having to scale up an entire monolithic application because a single component is struggling with. Now, what is the difference between virtual machine and bare metal servers? Choosing a virtual machine over a physical one, also known as the bare metal server, is less about computing capabilities and more knowing about what you need and when we need it. Bare metal servers are all about raw hardware, power, and isolation. They are single tenant physical server completely void of hypervisor cycles and entirely dedicated to a single customer like you. Workloads that highly prioritize performance and seclusion, like data intensive application and regulatory compliance mandates, that are typically best suited for bare metal servers, especially when deployed over sustained periods of time. E-commerce, ERP, CRM, SCM, and financial services applications are just a few workloads ideal for bare metal servers. So when would we place a hypervisor on the top of the bare metal hardware to make it a virtual machine? When our workload demands maximum flexibility and scalability, and the virtual machine effortlessly drives up server capacity and increases the utilization. This is ideal for moving from one virtual machine to another, resizing datasets, and dividing dynamic workloads. So that's all related to the VMs versus bare metals and the containers. Don't get confused between the containers and the virtual machine and the mini operating system which we came out in the Windows Server 2019. So that's all for today, and if you're having any queries related to this topic or any other topic, you can just reach out to us on itsfun.com or drop a comment on the comment section below. Thank you. Thanks for watching. Do like, share and comment our videos. Also subscribe to our channel.